My humble introduction is in the video description. Let's dive into the world of data analytics. It's less about ones and zeros and more about turning chaos into clarity. Today we will cover the essential components of data analytics. We will discuss how to collect, ingest, store, process, and visualize data. And we will see a few schemas to better understand data flow and services. A little bit about technical terms. Data ingestion is the process of importing large assorted data files from multiple sources into a single cloud-based storage medium, a data warehouse or database. In data ingestion, we have two main methods: batch data and streaming data. Batch data collect and organize a lot of information all at once. Streaming data, think of it like listening to your heartbeat. Every beat is a little piece of information. Streaming is continuous flow of data that is generated by many sources at high speed. Process and analytics. Processing data typically involves transforming it from one form or structure to another to prepare it for analysis. This process can be encompassed by terms ETL, extract, transform, load, and ELT, extract, load, transform, which are two common approaches in data handling and analytics. Analytics, the process of discovering, interpreting, and communicating patterns in data to help identify insights and make informed decisions. Data analytics is the collection, transformation, and organization of data to draw conclusions, make predictions, and drive informed decisions making. By the way, Netflix uses analytics to select movies, create content, and make this. Catalog and management. A data catalog is detailed inventory of all data assets in an organization. Management is the process of collecting, storing, securing, and using an organization's data. Data lake is centralized repository designed to store, process, and secure a large amount of structured, semi-structured, and unstructured data. We'll talk about data lake later, and I will explain what is the difference between data lake and data swamp. Let's look at our map of AWS universe in data analytics solar system. It's less about stargazing, it's more about data gazing. We have various data sources such as applications, SQL, NoSQL database, file shares, devices, logs, media, and IO device of my dog. These sources are like stars shining their wonderful light across the galaxy. To capture this enriching light, which makes our life more interesting and fun, let's explore the methods of data ingestion available to us. Batch data ingestion and streaming data ingestion. Let's examine the AWS services responsible for data ingestion. Services for streaming data, it's Amazon Kinesis, encompasses several specific services. It's data streamings, video streaming, and Kinesis Data Warehouse. This is Amazon Kinesis Data Streams for ingestion of streaming data with 1 second delay. Amazon Kinesis Video Streams for ingestion and storage of streaming video data typically has latency range from 1 second to 10, depending on the player, network connections, and use case. Amazon Kinesis Data Warehouse for delivering streaming data with near real time. It's delay 1 minute to destinations like S3 or Redshift. Kinesis Data Stream, it's fully managed, scalable, serverless, and near real-time data streaming service. It's designed to handle large volume of data with milliseconds latency, available 24/7, and data retention can be configured from 24 hours to 1 year with additional costs for extended retention. Amazon Kinesis Data Stream are under the hood of several AWS services, acting as the engine that drives their data processing capabilities. Services like CloudWatch, IoT Events, EventBridge, Kinesis Data Warehouse. It offers high throughput up to 1 megabyte or 1000 records per second per shard, ensuring data is available for immediate analysis. In contrast of Amazon CloudWatch, metrics are reported every 60 seconds, making them more suitable for monitoring trends over time rather than real-time processing. Similarly, Amazon Kinesis Data Warehouse has minimum buffer time of 60 seconds before delivering data to destinations like S3 or Redshift, which is ideal for batch processing, but not for scenario requiring instant data analysis. It's best practice to enable shard level metrics with Kinesis data streams. Kinesis data streams sends additional shard level metrics to CloudWatch every minute. This can help you pinpoint filing consumers for specific records or shards and identify hot shards. Use cases that require the ability to process and analyze data in real time with minimal latency. Data Warehouse, fully managed service for delivering new real-time streaming data. It's 1 minute to destinations such as S3, Redshift, OpenShift, any custom HTTP endpoint or HTTP endpoint owned by supported third-party services provider like Datadog, Dynatrace, MongoDB, etc. You configure your data producers to send data to Firehouse, and it automatically delivers data to the destinations that you specified. You can also configure Data Firehouse to transform your data before delivery. Let's look at another schema. For Amazon S3 destinations, streaming data is delivered to your S3 bucket. If data transformation is enabled, you can optionally backup source data to another S3. For Redshift destination, streaming data is delivered to S3 bucket. Amazon Data Firehouse then issues an Amazon Redshift copy command to load data from S3 bucket to Redshift cluster. And same behavior for OpenSearch service destinations and for Splunk. The diagram shows high-level overview of VPC flow logs delivery from source VPC to one of many destination types that are supported by Kinesis Data Firehouse. You can configure VPC flow logs to ingest directly into Kinesis Data Firehouse delivery streams. Optionally, the delivery streams can be configured to transform the source logs and then load the logs to various destinations, including S3, Redshift, and any HTTP endpoint that is owned by you or other parties. Let's go back to the schema and talk about Kinesis video streams. I found information about company Boston Dynamics. They use Kinesis video streams in Spot robot. Spot is an agile mobile robot from Boston Dynamics that navigates terrain with unprecedented mobility, allowing you to automate routine inspection tasks and data capture safely, accurately, and frequently. Users can view streaming video from the Spot robots on the demo monitor as well as their own device. Kinesis video streams make it easy to securely stream video from connected devices to AWS for analytics, machine learning, playback, and other processes. For reducing latency in KVC live media, look at the link in the description. Amazon Managed Streaming for Apache Kafka is fully managed service designed to process streaming data using Apache Kafka. It provides high availability, security, and minimal maintenance overhead, allowing you to focus on application logic and real-time fraud detection. Key tips from AWS: adjust message size for optimal latency. Smaller messages configured via settings like max message byte and batch size are processed faster, aiding quick fraud detection. Monitor CPU usage and disk space. Adjust data retention parameters. Speed up log recovery after unclean shutdown. Monitor Apache Kafka memory. Enable in-transit encryption. The best practices in MSK. I will include a link in the description for detailed explanation. AWS services for batch data. AWS database migration service. They're unsung heroes who make sure your data does not get lost in the move. DMS supports replication and ingestion of data from active databases to AWS, allowing continuous operation of the source databases. The following diagram displays a high-level architecture of the solution where we use DMS to move data from Microsoft SQL Server DB hosted on RDS to S3 bucket. For the replication data, you need to create and configure the following artifacts in AWS DMS replication instance. You control type or size of the instance based on the workload you plan to migrate. Source endpoint. For this use case, configure the source endpoint to the RDS for SQL Server database. Target endpoint. DMS supports several targets systems including RDS, Aurora, Redshift, Kinesis data streams, S3, and more. You can see S3 as target endpoint on the diagram. Replication task. Tasks that run on replication instance and connect to the endpoint and replicate data from source database to the target. DMS task, which will perform one-time full load to migrate a point-in-time snapshot and will then stream incremental data to the target S3 bucket. This way, any data in the S3 bucket will keep in sync with the source database. Let's go back to the schema. Amazon EMR, Elastic MapReduce, process big data across AWS data stores using Hadoop, Spark, and other big data framework. These frameworks are inherently designed to handle batch processing on large clusters. Let's look on the schema. You can see what is the difference between HDF, Hadoop Distributed File System, Distributed EBS Volumes, Amazon EMR File System. Actually, it's S3 bucket. EMRFS allows more flexible and cost-effective scaling by separating storage and compute, leveraging the scalability of S3. If you will see on the exam, for example, the most cost-effective, choose EMRFS, it's actually S3 bucket. Another best practice increasing EMR access performance to S3, implementing hash function. Amazon S3 organizes its storage based on the name or prefixes of the objects you store. When many objects have similar starting names or prefixes like dates in sequential order, they tend to get stored close to each other in S3 infrastructure. This clustering can lead to insufficiencies, especially when you try access many files at once, because the system has to retrieve a lot of data from the same area all at once. This is similar to many people trying to enter or exit the same doorway at once. Things can slow down. When you use hash function to create object names or prefixes, it mixes up the names so they appear random. For example, instead of storing files in sequences like 2021 0101, apply hash function might change this name to something like A7F4/2021 etc. This randomness spreads the file across different areas as free infrastructure, just like spreading out the crowd at multiple doors rather than one. Using hashed prefixes reduces the chance of creating hotspots where too many requests hit the same part of S3 infrastructure at once. To addition to, you can look at S3 Packet Express one zone. It's 10 times faster than standard storage, but remember you need to check the region where this feature is available. Let's look at data sync. It automates and accelerates moving and replicating data between on-premises storage system and AWS storage services like EFS and S3. The magic with AWS Data Sync lies in its agent-based architecture, comprising the following components: AWS Data Sync Engine, agent, locations, task execution. Picture 6-step dance routine. Construct EC2 data sync instance, generate and activate data sync agent, configure source and destination locations, create task to initiate data transfer, observe the progress of data transfer. Let's talk about transfer family. Facilitates the ingestion of data through secure protocols like SFTP, FTP, and FTPS. RDS can support batch operation through SQL queries, which can be executed to perform batch processing tasks. Snow family storage, very cold storage, consists of physical devices, AWS Snow Cone on the left side and Snowball on the right side with this QDoc. For moving extremely large volume of data into and out of AWS, as you can see, there is no AWS Snowmobile because it's no longer available. As of March 2024, AWS has phased out Snowmobile as part of broader cost-cutting efforts amid slow sales growth. Use cases: it's ideal when high volume data transfers over the internet are impractical due to large data volumes or limited connectivity. What benefits: it provides secure and efficient way to transfer terabytes to petabytes data. The data is encrypted and physical transfer avoids the constraints of net bandwidth. We will explore 5 key AWS services that serve as orchestrators for batch data workflow. AWS Glue is ETL service that prepares and combines data for analytics. It acts as a powerful orchestrator for complex data loading and transformation tasks. Use cases: it automates the process data extraction from various sources, transform this data according to specific business rules, and loads it into data stores like S3, Redshift for future analysis. Let's look at the schema, and you can see AWS step function as orchestrator. orchestrator. In this solution is demonstrate mechanism to integrated data preparation done by analysts and science to standard glue ETL pipeline using step function. Prepare, transform, and orchestrate your data using AWS Glue Data Brew, Glue ETL, and step function. To demonstrate this solution, being prepared and transformed publicly available New York City bike trip data to analyze bike riding patterns. The datasets has few attributes. Use it data brew to prepare and clean the most recent data, and then use the function for advanced transformation in AWS Glue ETL. For data brew steps, we clean up the dataset and remove invalid trips where either the start time or stop time is missing or the rider genders is not specified. AWS Glue Data Brew is a visual data preparation tool that allows data analysts and data science to clean and normalize data without writing code. After Data Brew prepares the data, use it Glue ETL task to add new column, trip duration, and populate it with values. After performing the ETL transformations and after performing the ETL transforms and store data in a free target location, we can use Athena to run interactive queries on the data to find the most used bikes, to schedule maintenance and start stations with the most trips to make sure enough bikes are available at the stations, and create interactive dashboard using Amazon QuickSights to gain insights and visualize the data to compare trips count by different riders, age groups, and user types. As you can see how it looks like Amazon QuickSights. Another schema show how we use Glue as orchestrator. This new file uploaded in S3 or time-based schedule is triggered, and orchestration workflow is triggered using step function, Amazon Managed Workflow for Apache Airflow, or Glue Workflow, depending on business requirements. Workflows are also triggered using predefined and time-based schedule to process file at certain interval. What is Amazon Managed Workflow for Apache Airflow? It's managed service that simplifies running Apache Airflow on AWS. It handles the setup, scalability, maintenance of Apache Airflow environment. Apache Airflow is an open source tool used for orchestrating complex computational workflows and data processing pipelines. What features available? It's automatic airflow setup, scaling, built-in authentication and security. It's IAM, role-based authentication and authorization. It runs in VPC, data encrypted with KMS key. Public and private access mode offers both public and private network options for access airflow web server, controlled through VPC endpoints and IAM policies. Streamlined upgrades and patches, workflow monitoring, CloudWatch, and worker fleets, which allows ECS and Fargate for scalable and efficient management of Airflow workers. On this architecture includes components such as Apache Airflow scheduler workers running as Fargate containers with private subnet AWS, often VPC. Each environment has its own dedicated Apache Airflow metadatabase managed by AWS and accessed via VPC endpoint. Integration with AWS services, S3, Redshift, EMR, and others. It also supports data processing tools such as Hadoop, Presto, Hive, and Spark, which is wonderful. AWS Batch enables developers to efficiently run 100 to 1000 of batch computing jobs on AWS, dynamically provisions the optimal quantity and type of compute resources, CPU or memory, based on the volume and specific resource requirements of batch jobs submitted. Use cases. This service is perfect for processing large number of jobs as part of data analysis, image processing, or any computational work where jobs are independent of each other but collectively from substantial workload. Data pipeline is web service designed to facilitate and automate movement and transformation data between AWS computers. It can regularly transfer data at specified intervals, orchestrate the transformation of data in scalable fashion, and ensure that data transparency are reliably met. This makes it ideal for regular high-volume data processing tasks like daily reports, data synchronization, or archival. Step function is orchestrator, maestro. Step functions coordinates multiply AWS services into serverless workflows so you can build and update applications quickly. It manages sequences of tasks and ensure they execute in order and as expected. Step functions is useful for complex workflows that require multiple steps, involve conditional logic, or need long-running multiple steps orchestration across services. It can coordinate tasks such as data transformation in Glue, followed by data analysis. Let's look at the application integration. Amazon SNS use it for pub/sub messaging and mobile notifications. In data analytics, SNS can trigger notifications based on the certain data coordinations or thresholds being met, such as sending alerts when data processing is complete. SQS acts as a message key service to decouple and scale microservices, distributed systems, and serverless applications. In data analytics, SQS can be used to buffer and batch workloads, managing data ingestion flow into processing or storage systems. Event Bridge serverless event bus that connects applications using data from a variety of sources. Event Bridge can route real-time data streams from AWS services, integrated SaaS applications, and custom sources. AppSync is managed GraphQL service that simplifies data synchronizations and manipulation across mobile and web applications. In data analytics, AppSync can facilitate real-time data updates and seamless data operation across different data sources. Amazon MQ managed message broker service for Apache ActiveMQ and RabbitMQ. Amazon MQ useful in data analytics architectures for integrating legacy applications that use traditional message brokers, ensuring reliable message delivery. Appflow provides secure and automated data transfer service between AWS services and SaaS applications. In data analytics, Appflow enables seamless data flows into AWS from external sources like Salesforce, ServiceNow, or Google Analytics without writing custom integration code. AP Gateway manages IPs at any scale. It can act as front end for applications to access data, services, or business logic, facilitating secure and controlled access to data sources for analytic purposes. Step functions, as I said, it's Maestro, coordinates multiple AWS services into serverless workflows as you can build and update apps quickly. In data analytics, step functions can orchestrate data processing tasks and involve multiple steps like data transformation, loading, post-processing. Okay, let's look at processing and analytics. Data Glue, as was mentioned, fully managed extract, transform, and load service that simplifies preparing and moving data from various sources to data store for analysis and machine learning. Let's jump to the schema, look at the architecture patterns where used services from Glue production family to build data pipelines. Here data is extracted from various sources, including transactional data sources such as customer relationship management, enterprise resource, on-premises databases such as Oracle, SQL Server, on-premises data stores, SaaS applications such as Salesforce. Here for a job orchestration, use it AWS step functions. As you can see, for data processing, use it Glue, Data Brew, Glue Jobs, Glue Studio. The job orchestrator triggers a Glue workflow to crawl the location of the file and build or update Glue data catalog. Glue data catalog contains references to data that is used as sources and targets of your ETL jobs in Glue. Processes and transforms data and data format, data quality and integrity checks, deduplications, transformation, and so on. Loads data after processing and transforming to data targets, including S3, Redshift, RDS, Aurora, OpenSearch services, or Amazon DynamoDB. Let's take a look at another schema, building data lake. Data extracted from various sources like transactional data source, approximately same previous schema. Again, job orchestrators, as new file is uploaded into S3, Lambda function or event-driven Glue workflow triggers orchestration workflow using step function, MWIA or Glue workflow, depending on the business requirements. Workflows are also triggered using predefined and time-based schedule to process file certain intervals. For processing data, use it Glue, Glue Studio, and services, and EMR. You can analyze the archived data in S3 using Amazon Redshift Spectrum. The presented diagram illustrates this process. With Amazon Redshift Spectrum, you can efficiently query and retrieve structured and semi-structured data from file in S3 and easily analyze the archived data in S3 without having to load it back in Redshift tables. For future analysis of your archived data and frequently accessed data in the cluster's local disk, you can run queries joining Amazon S3 archived data with tables that resides on Amazon Redshift cluster's local disk. S3 use it for storage data lakes, as staging area for data, and as data source. There is different storage classes. On the right side you can see three very called Glacier storage classes. Is a cloud storage services that can be used for compliance requirements, data archiving, backup, and disaster recovery. In the center you can see 10x faster. It's about Amazon S3 Express 1 zone. It's high performance single available zone storage class, purpose built to deliver consistent single digit millisecond data access to your most frequent access data and latency sensitive applications. Super turbo fast and reduce cost by 50% compared to S3. Available only in few regions: US East, North Virginia, US West, Oregon, Asia Pacific, Tokyo, and Europe, Stockholm. Hope will be much more. Go back the schema and one more time look at the improved performance to S3 hash function and go back. Amazon Redshift common for data warehousing, analytics, and as target for data loads. Also support querying data in S3 via Redshift Spectrum. Did you know what burger and fries are related? Because McDonald's uses Redshift to run global workloads for operational reporting and dashboards. I will not deep dive into Redshift. One tip: how changing cluster encryption. You can modify an unencrypted cluster to use KMS key encryption, use AWS managed key, or customer managed. When you modify your cluster, enable KMS encryption, Amazon Redshift automatically migrates your data to new encrypted cluster. You can also migrate an unencrypted cluster to an encrypted cluster by modifying the cluster. During the migration operation, your cluster is available in read-only mode and the cluster status appears as resizing. If your cluster is configured to enable cross AWS region snapshot copy, you must disable it before changing encryption, and you cannot enable hardware security module HSM encryption by modifying the cluster. Instead, create a new HSM encrypted cluster and migrate your data to a new cluster. Let's look at the schema. As you can see, S3 in the center, and there is AWS Lake formation, centrally governed, secure, and global shared data for analytics and machine learning. Let's look at another schema. As you can see, S3 central core of data lake, and below this you can see data transformation tools layer. Without this layer, it will be data swamp. What does it mean? It means data unstructured. It's a mess. It's data swamp. When we don't have this layer, it's a swamp. If we have this layer, our data well structured, prepared, transformed, and filtered, etc. It's already well structured data for analytics and only relevant data. It means you have data lake. It's the difference between data lake and swamp. Okay, look at the user access. AWS AppSync. This service allows developers to create scalable and secure GraphQL APIs. In terms of user access, AppSync integrates with Amazon Cognito to manage user identities and access, ensuring that only authenticated and authorized users can access the API and those data. API Gateway. This service acts as a front door to manage all the API calls, allowing developers to authorize access to data and services using various AWS authorization mechanisms, including Cognito user pools. API Gateway can verify access tokens from Cognito directly, providing secure way to control access based on user identities or user group membership. Cognito primarily a user authentication and identity service. Cognito integrates seamlessly with both AppSync and API Gateway. It handles user registration, authentication, and access control, ensuring that only authenticated users can access application and data. Catalog and management. AWS Glue Data Catalog acts as a central repository that stores metadata about your data assets. It integrates with other AWS Analytics and data processing services, allowing them to reference metadata to efficient data management and query optimization. Data lake formation simplifies the creation and management of secure data lakes. It handles data collection, cataloging, security policies, and permissions, ensuring that only authorized users access data. Lake formation also manages permissions for accessing the data cataloged in Glue Data Catalog, facilitating secure data sharing across services Redshift, Athena. Redshift utilizes Glue Data Catalog for schema management and Redshift Spectrum queries. This integration allows Redshift to perform SQL queries directly on data stored in S3, using metadata stored in Glue Data Catalog, which improves management and accessibility of data. For visualization, you can use QuickSight, use it for business intelligence, data visualization, and creating dashboards. OpenSearch service, use it for search, log analysis, real-time analytics, visualization through dashboards. Athena, use it for querying data directly in S3 using SQL. Near real-time analytics using Redshift streaming ingestion with Kinesis data streams and DynamoDB. As shown in the diagram, DynamoDB table changes are streamed into Redshift through Kinesis data streams, and Amazon Redshift streaming ingestion for near real-time analytics dashboard visualization using QuickSight. For security and governance, you can use all these services. I just briefly show you how it looks like lake formation on the schema and for what this. Lake formation helps you centrally govern, secure and globally share data for analytics and machine learning. Lake formation permissions are enforced using granular controls at the column, row and cell levels across AWS Analytics and machine learning services, including Athena, QuickSight, Redshift Spectrum, EMR and Glue. That's it. I highly recommend check out the AWS blog for deep insight into any services you are interested in. There you will find detailed schemas, descriptions, and even CloudFormation stacks for well-structured and reviewed infrastructure. This info is trusted, reviewed by seasoned Amazonians. Thank you them. Another fantastic resources is AWS reInvent, where presentations cover everything from pitfalls and best practices to new features and limitations. They offer invaluable explanations and use cases. Armed with this knowledge, you can bring your clients the best practice to the base. I will share this schema in the description along with the links best practice. Thank you for tuning it. If you have got experience with these services and know some best practice pitfalls, I would love to hear from you in the comments. Au revoir.